Hey everyone, welcome to our professional development panel on careers in industry with a theme of computational neuroscience. I'm so excited to see everyone. So I'm Ella Batty. You're probably sick of me by now. I'm the exec director of Neuromatch. You've also seen me in your curriculum materials. And then we have some lovely panelists joining us. So Ari, do you want to introduce yourself?
Sure. Hi, everyone. My name is Ari Morkos. I'm a researcher at FAIR in Meta AI research, mostly focusing on understanding neural networks and kind of ways to generally make them better. I got my PhD in neuro, doing experimental neuroscience, and then moved over. So happy to talk about lots of that stuff today.
Jessie, do you want to introduce yourself?
Yeah. Hi, everyone. I'm Jessie. Similarly, I also got my PhD in neuroscience, specifically cogneuro from a human neuroimaging perspective. And I currently am a data scientist at the Pacific Northwest National Laboratory, which is one of the U.S. Department of Energy's national labs.
And Guillermo?
I'm Guillermo Secchi. I forgot what I did in my PhD already, but what I'm doing now is I'm in IBM Research, and I direct the program on computational neuroscience and neuroimaging. And we work across academia and industry on problems related to neuroscience in general and psychiatry in particular.
Great, thanks, all. So just to give an overview of how the session will go for everyone in the audience, I have some questions that I'm going to ask the panelists. But after that, we're going to pretty quickly get to your questions. So you should be asking questions in the Ask a Question chat thing at the bottom. And then you can also upvote people's questions. So that will help us see what questions people are really excited to have asked. So please ask lots of questions there, because most of the hour will be based on your questions. All right, so I'll get started with some of my own questions though. So I would love to hear where everyone kind of began your studies. So did you start in neuroscience, computer science? Where did you come from? Jessie, do you want to go first?
Yeah, sure thing. So I did my undergrad at UC San Diego, and I enrolled in biology neuroscience and quickly discovered cognitive science, which was a more interdisciplinary approach, I thought, to understanding the brain. So I got to take bio and psych, but also anthropology and computer science and linguistics. And so that suited my interests. And after that, I had a depressing half year working random jobs until I got my first job at a neuroimaging lab, not doing neuroscience, unfortunately, but the closest I could get was working for a database administrator on a neuroimaging archive, where I actually started to learn how to code for the first time more than I learned in a course. So I learned SQL then, and at the time I was like, this will never what? And then I was eventually about to run out of my health insurance, and I was like, it's time to get a PhD. And so I went to get my PhD in neuroscience, and entered it kind of thinking that I love neuroscience. I didn't know what to do next, and it made the most sense, but also still not sure that I wanted to do the academic route. So for a while, I thought I wanted to go into science writing and science communication. And the longer I stayed and the more I analyzed data, the more I realized I just really loved working with data and programming. And that led me to my current role in data science at PNNL, which is sort of a hybrid of industry and academia. So it's still highly research-based, and you can sort of steer whether you want to work more in tools and products versus working more in the sort of still being an academic researcher.
Cool.
And then pretty early career. So I just finished my PhD just about in December. And full disclosure, you may see my cats and husband walking by back and forth.
Well, congrats on finishing your PhD.
Thank you.
This is exciting. Ari, what about you? What was your beginning story or origin story?
Yeah, sure. I also went to UCSD for undergrad, actually,
Wow.
and studied neuro there. And that was my first exposure to research. Was I volunteered in Fred Gage's lab working on adult neurogenesis, and from a molecular biology perspective. And then kind of near the end of undergrad, realized, I wanted to go get a PhD. I'd been debating, but I initially thought I wanted to be a neurologist. And then I realized that might be sad to just tell people that they have incurable diseases all day. So then I decided I wanted to get a PhD and I was vaguely interested in circuits. So I did my PhD at Harvard, working with Chris Harvey, working on teaching mice to count and then analyzing neural activity in parietal cortex while they do that to try to understand the neural dynamics underlying decision making. And the first half of my PhD was very focused on training mice and anthropomorphizing and really working in building microscopes and all that jazz. And then I ended up with this kind of huge data set of neurons by time, and all of a sudden had to make sense of it. And I didn't really know how to do that. So that's what got me to start really focusing on machine learning. I also was a self-taught coder, as many neuroscientists are in the beginning of grad school. But I started getting into machine learning. I started with Andrew Ng's Coursera course, and then started devouring YouTube lectures. And since I was still in grad school, I was able to take some grad courses in ML, and just found that I, was much more taken with that whole side of things than I was with experimental neuroscience. And then I also kind of was going back and forth about whether or not I wanted to stay in neuroscience, but kind of ultimately realized that I loved solving and trying to understand complex systems. But for me personally, solving the brain in particular was not critically important. That was at the same time. This was in kind of 2015 when I was ending my PhD. And that was at the same time that the deep learning explosion was just starting. I went to NIPS or NERPS that year, and it had 2,000 attendees. And this year there were 10,000 submissions. So it has grown. And was fortunate enough to be able to get a job at DeepMind, coming straight out of my PhD. So I moved to London and worked at DeepMind for 2 years, working on deep learning research before moving back to the US and to FAIR about 4 years ago. And in both roles, my primary focus has been basic research. So I don't really work on products or anything like that. And my main output is publishing. So kind of, I think I think it's very fortunate to be kind of in this particular moment in time when industry is willing to support open science and kind of enable us to do that without, some of the downsides that might be present in academia, like having to fundraise, for example.
Thanks. And Guillermo, how did you get started and reach where you are?
With some effort, I was able to recall some of what I did before. So I started, I did as an undergrad physics back in my home country in Argentina. And I focus on chaos theory and dynamical systems. And from just to show that my trajectory is not completely random, I also got courses in philosophy. Then for my PhD, I did that in Rockefeller University, and I did physics and biology. So I work on molecular motors, visual neuroscience, songbirds, canaries, and finches. So it was a lot of different things, but the main focus was neuroscience. And then I did a postdoc in psychiatry at Cornell, and that really abstracted my career, my outlook very much. The first time I interacted with a patient, I was deeply shaken. I was able to start as a researcher in IBM research, and initially was computational neuroscience, but I was able to steer that towards more directly neuroscience, and in particular psychiatry. And now, like I said, we are working on industrial applications, not products, just basic research with industrial partners, but also we have academic collaborations, NIH programs. So as Ari was saying, very lucky. The main focus of what we do is research, and it's supported by industry. It has certain advantages with academia. So that's a very short story.
So I'm curious to hear more about those advantages. Obviously, we're at the industry panel, so you all chose to go into industry, not academia. We have academia panels next week. So Ari, you mentioned like not having to fundraise. Is there anything else? I mean, what else really drove that decision to choose this path?
Yeah, I think there are a number of things that are advantageous. So not having to write grants is definitely a big part of it. That never seemed particularly fun to me, and I didn't really want to do it. You also don't have to teach as a mandatory thing, although there are lots of opportunities to mentor and to hone those skills in industry, or at least I've encountered lots of opportunities to do that. Generally, work-life balance, I'd say, is better in industry. It's hard to make a blanket term about that because there are, of course, companies that have unhealthy cultures with respect to that. But on average, I think people are much more likely to take weekends, for example, and to be out of work by 6 or 7 o'clock at night relative to academia. And then, of course, financially, industry is much better than academia, especially, once you're a postdoc and your, salary had gone up minimally from grad school and stuff like that. So those were a lot of the advantages that appealed to me.
And is there anything you miss about academia?
So I'll be honest, not really.
Well, that's good. Glad you're happy.
I don't think I've ever really regretted leaving academia. That said, I also will say that I'm in a pretty privileged position in which I'm able to still do basic research. That is not the norm for industry. I think, in general, the expectation is if you're in industry, you're probably going to be working on something that makes money in some capacity or another. There are some positions, places like FAIR, but the demand is much higher than the supply for those opportunities. So I think that if I had to give up doing basic research, I think that would have made the decision a lot more difficult for me.
So Jesse, do you have anything else that kind of drove your decision?
Yeah, well, I think as I mentioned, I always kind of had one foot out the door, and I'm not sure why that was, but I think I liked teaching and I liked all that, but I also had this like insecurity about being good enough for a tenure track position, and there's a lot of like imposter syndrome that I had throughout my academic coursework, and it has not stopped in industry. I'm like, you gave me this job, but like Ari, I'm also still doing I'm doing a combination of basic research and working on products. What I like about my company is that you are able to do both. What's nice about the National Lab is it's still very, you're encouraged to kind of pave your own path. And if you want to still be an academic, you can still write grants and bring in funding. I came in thinking I would never want to do that and that I was done writing, and have gotten sucked back in a little bit. And so we'll see. But the cool thing is sort of I was on some projects. I wasn't feeling like I was learning the kinds of things I wanted to. And like I put it out there to my friends at the company, and like it just materialized in new opportunities. And so it's sort of like at least where I am, at ask and you shall receive, and you can kind of to some extent pave your route. And there is a kind of cool agency there that is not as high pressure, I think, as I experienced in academia, where the sort of projects that you're working with are completely your baby, and you can't step away from them because like you have to. So that's been really nice, but that could be hard for people too, like where our work is really dependent on the government sponsors that fund them, and also the Congress cycle approving funding. And so you sometimes lose funding, and you have to be able to let that go. So it's a different animal.
Yeah, it's interesting what you said. I think one of the common narratives is, academia is more flexible because you can choose your research project versus industry telling you what to do. But it sounds like all of you are shaking your head vehemently. You really disagree with that. Guillermo, do you want to tell us more about that?
Absolutely. And that's, besides the advantages that, Ari and Jesse already mentioned, and salary is not one of the least of them, definitely. For me, the real driver was I saw the possibility of having much more academic freedom, and it might sound counterintuitive in industry. I mean, again, industry is really wide, but we're talking about very specific places, right? So in avian research, I can tell you for 10 years, I did absolutely whatever I wanted, and no questions asked. I'm chasing money, but it's incomparable the amount of the effort that I have to make to chase money compared to what my postdoc advisor at Cornell was doing. Mm-hmm. In his office, 12 hours a day writing grants. There is no comparison. So something happens in a place, in a large company like Facebook or IBM, you can always find someone that will be interested in what you're doing because it's so big that, if you know how to present your intellectual pursuits in the right manner, you can always find someone that would be interested in what you're doing. So, and in particular, I know, physics is a bit different, but in neuroscience, and even more in psychiatry, you have to work on one thing and one thing only, right? And that's it, because you have to apply for grants, and then in the committees that review your grants, everyone is doing the same thing, and they might say, well, this is good, but does not belong in this committee. That's it, end of story, right? So, following the thing, one thing that I miss in academia is students, because students, are fresh blood, they have new ideas. It's possible, I am supervising students in different academic institutions. But that's, for me, it took some time. But that's the one really big difference between an industrial lab and academia. But regarding the intellectual freedom, that's not a positive difference for academia. If anything, is the opposite.
Yeah, if I can add to that, I think, I think there's this myth that you really have academic freedom in academia, and you have just as many restrictions as you do anywhere else, right? You have to do the work that's going to get funded. And, you know, if you're pre-tenure, you have to do the work that's going to get you the high-profile papers that are going to enable you to get tenure. As a postdoc, same sort of deal. So you have some control, of course, of what broad research area you want to work in. But if you want to work on something really niche, you're going to struggle. You're going to have a really hard time getting money, and you're going to have a really hard time getting anyone to care. And, you know, unless if it hits, you're not likely to get tenure. You know, I think once you pass tenure, this gets better, of course, but it still doesn't go away. You still need to fund your lab, and you're still at the mercy of the fundraising institutions. Within industry, that still exists, but it's very broad, right? So if there's something that you are interested in, there is probably a company that is focusing on that, and that is trying to find some way to make that useful, that you can use. The one other thing I'll say is about things I miss. I also miss students. I think I forgot about that one, but that's a big one. I've had a lot of opportunities to work with really talented students while in industry, but they tend to be shorter term engagements. So I tend to work with interns who come for a summer, and then maybe they stay on for a couple more months. So I work with them for 9 months or a year. And I love that. That's one of my favorite parts of my job. But I think, you know, as a advisor, as a PI, you get to really kind of take a student who's fresh out of undergrad and watch them grow and help them to develop and kind of blossom over the course of 4 or 5 years. And I think that would be nice, but that's much harder to do in industry.
If I could just add one more thing, I think it plays well with what you folks are saying, just that when you go into industry as a researcher or scientist, you're not siloed sort of with your own field. And so you can meet people with a lot of different backgrounds. And I think that fosters really way more interesting interdisciplinary research, because you've been trained in different things and can bring more to the table. So, you know, on some of my teams, I work with mathematicians and electrical engineers and statisticians and geographers, and we're working on the same projects and bringing the methods and ideas that we've been trained in to a new space. And so I think that's really cool and gives you an opportunity to learn a lot more. As they're saying things we miss about academia, I miss the free food.
Very specific. Yeah, Ari, you've got all the free food you want.
One more comment, actually, building off of Jesse's interdisciplinary point. I would strongly recommend that anyone's kind of that's thinking about this and interested in maybe kind of science organization, read this book called The Idea Factory. It's a history of Bell Labs. And famously, one of Bell Labs' founding philosophies was that you should mix people from different fields, and that you put mathematicians next to biologists, next to chemists, and all this sort of stuff. And I think it's just really fascinating, and really thinks about kind of different ways to organize science and to, you know, make science a productive and fun enterprise beyond kind of the standard academic system that we usually think about. Really good book. Idea.
That's interesting, because, you know, IBM Research was founded on the blueprint of the labs, right? It was almost a replica, and something that, you know, is part of the folklore in IBM is that the demise of Bell Labs was too much of a disconnect between what the lab is doing and the company, right? So that's a challenge in industry, right? Finding the right balance between the freedom that you have to provide the scientists and the need to, you know, keep the business going, and, you know, keep the CEO and the shareholders happy that you're not doing something that is completely useless. So that's a challenge, but it's a good challenge, right? You know, because if you've solved it, then you have, as Jesse was saying, then you can do things that are probably very difficult to do in academia, right? Like take the projects and make it work end to end.
So It's been it's been great to hear about why you all went into industry. I think our students would love to hear how you made that transition. So how did you make the connections you needed to, learn the stuff you needed to make that transition? Jesse, since you did this very recently, do you wanna tell us first?
Sure thing. Yeah, so I, near the end, I'd say in the last year of my PhD, I started more hardcore networking. So I got onto LinkedIn and I started reaching out to people. It was a little soul crushing. I'd say like for maybe every 10 people that I reached out to, I'd maybe get one person back. And that might even be over, like I would have to do it in spurts where I could really divorce myself emotionally from it, because it's like a lot of people are busy and, or don't check LinkedIn or just don't want to respond. And so, I sent out mass things and some people were really nice. And so I just talked to a lot of folks that were in fields that I thought were interesting. They weren't always data science. And it was during the pandemic. So I went on Eventbrite and started seeing like seminars and conferences that I could go to for free, and would reach out to people that I thought were interesting. And I think at some point, someone had mentioned the National Lab System to me. I don't know who of all the people that I started talking to, and it led to me looking at their job postings, which led to me applying to an internship, and I almost missed the call. And when I did talk to them, I hit it off, and they just asked me to apply for a full-time position. I was prepared to take a year off of grad school, and I thought that I was going to just do hardcore, self-taught data science and do Andrew Ng's course, which I'd started, and a bunch of other things. And I have friends that have done that. I think I just got very lucky. But I know a lot of folks that have done boot camps and self-taught, and just did constant LinkedIn networking and applying, and eventually it pans out. But it was it can be a difficult transition to get into the field. But there's more and more opportunity for people that want to get into at least the field of like data science and more computational stuff that has overlap with neuroscience and deep learning. So yeah.
Thanks. Ari, do you want to chat about how you made this transition?
Yeah. So I second Jesse's point that networking is essential for this. Something I personally kind of hate doing. I'm an introvert. I don't like going and talking to random people that I have not met before. But it really is a necessary evil. I will tell you that when I hire interns and postdocs and residents, well, residents less so, but for interns and postdocs, it's almost always somebody that I have spoken to at a conference before, or that I've had some interaction before. So I have hired people who just send inbound, resumes, but it's much less common. And not necessarily people from labs I know or things like that, but people who, walked up to me at a conference and were like, hey, I'm working on this thing and I really liked your paper on whatever, and so on and so forth. So that sort of stuff is really important. And that was important in my journey as well. I went to my first machine learning conference was NeurIPS in 2015. And, I was very anxious about networking, but ended up, in some conversations with people from DeepMind. And that was really helpful at the time because DeepMind was one of the, machine learning focused places that generally valued neuroscience, which was not universally true back then. Nor is it now, but it's more, people are more on board with it now than they were in 2015 generally. I'd say I had people in 2015, I had the director of ML at a pretty major company say that they would view me as not having a PhD because my PhD was in neuroscience, and they kind of thought that was totally useless to anything related to machine learning. That's less the case now, but there are still people that have that viewpoint. But I was really fortunate in that I was able to then get that job at DeepMind and start working there, and then that was a real inflection point. And then changing jobs 2 years later was a lot easier because at that point I had lots of connections and so on and so forth. So I really would encourage you to network. I'd encourage you to email people who papers you liked, and tell them why. Don't just say you like the paper. That's not going to do very much. And try to talk to people and stuff like that. That said, I will note that I think my path would not work today. I think that was. I think I certainly got lucky with respect to being in the right place at the right time. I think if I were making the transition today, it would be through a residency program. And if you're interested in getting into ML research at one of the major research labs, I would strongly recommend residency programs. They're designed exactly for this purpose, and are places where kind of a non-standard background is viewed as a plus rather than as a detriment. So I think probably if I were to make that transition today, I would have done a residency for a year, and then tried to get a research scientist job after that.
And do you think a residency is better than an internship? What's the kind of pros and cons there?
They're different. A residency is longer term. Internships generally will be more focused on people who are already doing machine learning PhDs. Realistically, there are some you can have internships if you come from a pure neuro background, but it's a little bit more challenging generally. One of the things for residents is that because it's a year program, there's expected to be an extended period of time where you are not productive. And when you're ramping up and adapting to a new field, internships are about 3 months. Really, it's hard to do good research in 3 months if you hit the ground running, let alone if there's some substantial ramp up time. So I think that that's one of the things that makes internships a little bit more challenging in that regard. I see somebody asked what a residency program is. They're basically year-long programs that are designed to help bring new people into AI. Generally, you'll come into one of the big companies like FAIR or Google Brain. I don't think actually Brain is doing a residency anymore, but they used to, or Microsoft Research has one, and spend a year in that lab, usually working with some mentor who will kind of, help bring you into the new space.
Thanks. So, Guillermo, do you want to tell us how you made the transition, and any recommendations for students who want to make the transition now?
Yeah, Jesse and Ari emphasized the serendipity aspect of this. But you have to be prepared, right? So you have to be lucky. But if you are prepared, then you will take on the opportunities. And I think having a wide network, the wider the network, the better you are. So in my case, when I was finishing my PhD, I really wanted to do computational neuroscience, but not in the traditional way it was done at the time, which was pretty much, 1 neuron or a few neurons at a time. And I could not find the place. So I ended up doing a postdoc across the street from my lab in Rockefeller at Cornell Medical. And like I mentioned before, it was very influential. But then I was not looking for a job because I was just 1 year into my postdoc, and someone who did his postdoc in my PhD and also transitioned from physics, he was doing turbulence into genetics, got a job at IBM because this is when they launched the computational biology program. And he told me that there was an opening that was looked like it was made for me for computational neuroscience. And that was it. I applied and I got it. So, it was to a large extent serendipity, but I was prepared because, I knew what I wanted. I couldn't find where to do it. And then the transition to much more hardcore psychiatry that I'm doing now, that took me a while. But once you're in, things are much easier. So, I mean, the main advice is keep your eyes open, look at all the opportunities, have a large network of connections, trying to understand what people are doing. But also, I think, in particular, when you're doing a PhD program, you have to put some pressure on your advisors to offer you those opportunities, right? To get the experience, the knowledge, and the connection from your advisors, because not everyone will have the same career path, right? So I think that's also important, right? So the graduate schools should be more responsible for the career future of the students, and I think there is not enough of an effort in that direction from what I see in graduate programs.
I'd like to add a few things that came into my mind as Gam and Ari were talking. Perhaps, like Ari mentioned, it may be more difficult sometimes to get into machine learning or deep learning at the moment if you don't get lucky, because there's always that too. But I also think that I'm noticing more and more opportunities for neuroscientists in industry. When I entered my PhD as a cognitive neuroscientist with doing MRI, it was like, what is there for me? Like, I thought I didn't know what I could possibly do because I was like, I'm not a wet lab researcher. And I felt like to go into industry, I had to be working in a wet lab. And so I've just been noticing it because I kind of still look at LinkedIn. More and more, listings at some of the big tech companies looking for cognitive scientists, cognitive psychologists. And I'm noticing, I think, a couple places like, these big companies, Amazon, and having internships that actually ask for cognitive psychology or neuroscience backgrounds. And then even new companies coming out developing non-invasive neuroscience technology. So that I think is really cool thing to keep your eye on if you're interested in going into more of a neuroscience research in industries, that there are more and more companies coming out that are focused on actual neuroscience research. So MRI tech, FNIRS, even going into brain-computer interface research, where you would be able to apply a lot of ML models, but actually have the neuroscience chops. So you only, if you don't have that background, you at least have half of what you need and you can learn the rest. So which you're going to learn in the next few weeks anyway. So, I mean, you guys, you're going to be fine.
So that leads very naturally to our most top voted question. So you kind of started answering this, but Savali asked, what are the possible career trajectories in computational neuroscience in industry? So you just mentioned some of them, but what, are there other ones that the students should know about?
Well, maybe I can talk a bit more about directly let's say the healthcare space. I mean, I think there are tons of opportunities there, right? So I can mention we have worked with Pfizer. Now Pfizer, before COVID, decided to quit neuroscience altogether. But there are many other pharma companies that have a lot of programs around neuroscience that really require people with deep knowledge in neuroscience and computation. Everyone has to do computation anyway, right? Then there are many device makers, and for instance, we are working with a device maker for chronic pain simulation, and we have a program that has been going on for 6 years. And essentially, you require someone with a deep knowledge in neuroscience and a deep knowledge in computation. I work on quite a bit around language and voice. There are tons of programs of people that use NLP and voice analytics to diagnose different mental health conditions in industry, in established industry, in startups. So in the healthcare space related to neuroscience, but even beyond neuroscience, because patients in general end up with the sorts of serious comorbidities. Depression is one of them. So your knowledge in neuroscience is really required across a very large spectrum of healthcare conditions. So that's a gigantic space that requires graduates in neuroscience and computation and math and computer science. So it's and it's growing, as we know. This is a space that is keeps growing.
Yeah, I have a couple. I think there are a lot of these opportunities, and I'll mention kind of a couple directions. So I think the BCI direction is definitely going to be a big one. For example, you may know that, or you may have heard that Meta acquired Control Labs a couple of years ago, which was founded by a bunch of neuroscientists. And the explicit goal of that is to use wristbands to decode EMG signals and make that the future interface for VR and AR. So that's just one example, but I think that there are lots of branches in that direction where having expertise at the interface of these two fields is going to be tremendously useful. Also, just generally, ML for science, I think, is going to be a very, very exciting space over the next 10 years. I think, things like AlphaFold are just the beginning. And we're going to start seeing this for materials design and for drug discovery and for a whole bunch of stuff. There are already a bunch of startups that are founded on that basis of using ML to kind of have high throughput screening and candidate generation. Machine learning folks sometimes think that they can just go into a new field and just say, hey, I know machine learning. I have a hammer. Where are the nails? But that's not how it works. It really requires a close collaboration between domain experts and people with ML expertise. So I think that coming from background in biology and neuroscience provides lots of domain expertise that can be used very effectively in combination, and that's true whether you're a systems neuroscientist or a computational neuroscientist, or even if you're a molecular neuroscientist. There's lots of opportunities, I think, to be a domain expert working with ML for molecular neuroscience or things like that. So I think there are a lot of cool opportunities in those directions. And then one other thing that is worth mentioning is that kind of, I think we were focusing on kind of luck a little bit in the past answer session, and like I think it would be foolish to like take survivorship bias and just like ignore that as a factor. It absolutely is, but I think also luck favors the prepared is a phrase that I like, and I think before I moved into ML, I spent a lot of time reading papers and kind of had to like redo my qualifying exam in ML instead of neuroscience. So I think there are a lot of paths in that direction as well.
And we may say luck sometimes, and it could be related to the imposter syndrome I mentioned. Like, we talked about how important networking is. I mean, I would have never heard about national labs had I not been networking, even though I didn't actually get the position through anyone I networked with. So just the value of those connections, just talking and getting ideas and learning, getting what's in their brains into yours. But yeah, like I had mentioned earlier, looking into brain computer interfaces, because that's going to be big and or is big and will continue to be. Personalized medicine, perhaps, precision medicine. I always kind of wasn't sure how easy it would be able to stay in neuroscience. So I was always like, okay, well, what about health adjacent research? And right now I'm doing some of that and signals processing. It's not neuro signals processing, but biosignals. And so for me, it's close enough sometimes. But also, yeah, medical imaging technology. There's a lot of really new and cool applications or computer vision models being applied to actual neuroimaging data. So I think my recommendation is, yeah, having keywords that you look into and following them on LinkedIn and Indeed, and just getting email blasts. And occasionally you'll start to see things. I have friends that have gone into digital neuroscience positions. I didn't know that was a thing. So collecting like these keywords and lists of things that to start looking into. And she works with a bunch of, was a postdoc in neuroscience. She was planning on tenure track and blew us all away when she was like, I got a job in industry. So it's never too late. Yeah, I'd say those are the things that come to mind right now. And I will mention more if they come up.
One more thing that I meant to say and I had forgotten. I think that oftentimes, if you ask kind of somebody who's in their PhD or in academia, kind of like what they're an expert at, they'll give you, a very narrow answer. I'm an expert in, decision making in cortex or some particular thing. That's actually already a pretty broad area, but they focus on kind of what they study. I think that a PhD is not about the specific topic you study. I think that that's what you do in your day-to-day, but a PhD is really teaching you how to take very vague questions and ideas and concretize them and think critically, and know how to test things in a way that is effective and to the point. That is an incredibly generic skill. And that is a skill which is useful everywhere. Like why do so many academic people leave and go into consulting? That's effectively, consulting is getting presented with a new problem every month and basically saying, how do I begin to tackle this problem? So I think that this is something that I would find very encouraging, that I think the skills that you'll learn in a PhD in neuroscience are really very portable. Maybe not the specific papers you remember, but the meta process of how do you do science is just so incredibly valuable.
So that leads pretty well into another question that Luis Fernandez asked. So you mentioned these skills that you learned during a PhD, and they asked, what industry roles can a computational neuroscience PhD attain which someone with a master's cannot?
I'd say to some extent there's sometimes gatekeeping. Just, companies might want someone with a PhD, not to say that someone with a master's couldn't do anything that a PhD did. You may or may not have gotten more research experience with a PhD, just because certain master's programs don't require research. And so if it's a research heavy role, perhaps that might be, it would be helpful to have had that experience, whether or not you had a PhD or master's.
Yeah, I think PhD is just, as Ari was saying, is a proof that you can take a problem and drag it all the way to the end, kicking and screaming, but crossing the line. And that's what it's the first pass when you're going to hire someone, so that they're able to do that. But I don't think there is a particular prejudice. If you can do what you're expected to do, people will hire you. So, and I don't think there is a big difference, except for the fact that you have shown that you can do it, right? And you can do the process that Ari was describing. Right?
Yeah, I would say that there aren't that many in practice that really require a PhD. I think some titles require a PhD. So for example, you generally will not get the title research scientist, at big tech without a PhD, although there are some exceptions to that. Typically, people with masters would get research engineering positions. But in practice, there are tons of research engineers at FAIR who, for all intents and purposes, are identical to research scientists, and have led both the whiteboarding and kind of conceptual idea and the implementation of really complicated and impactful projects. One kind of point actually saying that maybe it's not worth getting a PhD is that if you enter industry after a master's, you get 3 to 5 years of career growth in industry, and that reflects more freedom, and that can reflect higher income and a whole bunch of other stuff. Whereas if you do a PhD, you're spending that on kind of this parallel track, and generally you will not cross over to the same level as if you had started as a master's and spent those same number of years. That said, to disagree with myself again, what I was saying about those skills in the PhD, I really deeply believe. I think that the skills that you get in a PhD are super valuable. Not to say that that's the only place to get it. Many mentors in academia are terrible and will not teach you those skills. But I think you're probably a little bit more likely to get that in a PhD than you are in industry.
I was just having this conversation with a coworker yesterday who had he had a master's, and he'd advised one of his coworkers to not go for a PhD, but he was like, but I think she should get another perspective from you too. So, and we were just having this conversation because there's definitely no right answer. But yeah, I definitely have felt that I'm just entering industry and it feels like starting from scratch and a whole new career in a way. So, I mean, that is something that you may feel if you, for the folks considering PhDs who have not entered it.
Well, and also the fact that you might expand your set of skills, right? If you do your undergrad in neuroscience and then you go for something more computational or vice versa, then that can provide you with a wider set of skills. But you can also learn many things in the job, right?
So another thing I'm not sure. Oh, go
ahead.
One thing I didn't do a traditional master's, so I don't know if you get experience with the master's, but during PhD, I found that I got a lot of science communication experience, which was very valuable just to networking. It just communicating your research and your work, having to constantly present posters and give little talks and it just lab journal clubs, you just get a lot of experience communicating, which is super valuable in any position when you have to share your research, and it becomes the more and more you do it, it becomes easier and easier and highly valuable.
In some ways might be more valuable in industry where you have to communicate science to non-scientists versus communicating only amongst experts.
Yeah.
So I think we just have time for kind of quick answers to one final question. So I'm going to amalgamate a couple, which is asking about postdocs transitioning. Is that kind of too late in your career stage to transition, or can you still transition into industry? Are there any pros from doing it at that stage?
Definitely not too late. It's never too late. It might take. There might be an on-ramp that's going to take some time to get into industry, and you will have to do that. But like I said, the point of a PhD is learning how to be a good scientist, and a postdoc is just honing those skills further. If you know how to do that and know how to learn, which you will likely have learned over the course of a PhD and a postdoc, you're definitely capable of moving into industry and into a position that's going to be exciting for you.
Any other thoughts on that?
I agree, Ari. I think postdoc should be abolished. I think it's not. You have to have a position, right? I mean, either like a student or you have a position. But if you're gonna do a postdoc from day one, think about your next job, right? Because it's not, overall, I don't think it's a healthy position, right? So try to go for a real job as soon as you can. That's my advice.
No offense to the postdocs in the audience.
Yeah.
All right, thanks. So I think that unfortunately we're coming up on the hour. So there's a lot of questions we didn't get to because there's so much to talk about. So some of our panelists will be in Discord, and we're going to have an industry careers channel there to continue the conversation. I see, and we asked a poll about where people are going, and most people said they're not sure between academia and industry. So next week we'll have panels on academic careers, and you can see if you're swayed one way or another after that. So before we wrap up, I'd just love to ask each panelist, do you have any kind of final words of wisdom to our students who want to make the transition about preparing for these jobs and making resumes or networking or anything? What are your final words?
I think academia has this sense that the only purpose of life is to do good science. And like, I love doing science, but life is a lot more than science. And I think that ultimately what you should optimize for is what's gonna make you happiest and make you feel the most fulfilled, wherever that's gonna end up being.
Yeah. And I would say, know what you want, have it clear, and if you have that, you will find the right place. There are opportunities, but know what you want, and then the rest will follow.
Yeah, and know that it's okay to stay in academia or leave academia. It's sort of this, I think, thing that is changing. Like right now, it's becoming like alternative careers from academia, but it's just sort of like, we know with the supply demand, there's just, it isn't the case that everyone who is an academic can stay in academia forever, or may not want to. And I think there's like a sense of a stigma of leaving that hopefully is changing. Because there's more and more ability to be a scientist outside of academia. And again, I think we've reiterated networking is key, and however you can do it, just it will be very helpful, and good luck.
Well, I want to take this time to thank all our panelists for taking the time to be here. This was a super engaging conversation. I'm sure our students think that as well. And thanks to all the students who came. And thanks for your enthusiasm. I'm sorry that we didn't get to 31 of your questions because you asked so many.